Well, this is John Black, Super Chemist. Walmart has a floodlight, right? That's another thing I wanted to bring up first of all. You don't want to get a LED that looks like one of those incandescent lights bulbs. You know what I mean? Because that's going to produce light going all over the place, three-dimensionally out as a sphere. You know what I mean? You want a floodlight type bulb that looks like this, a floodlight. You still want the kind that screws into a regular, light. But you want it to be LED like this. That way you can shine. You can have your reaction right here and shine this right, directly into the reaction, right? So, anyways, what Walmart has one of these floodlights, right? It's LED, only blue LED. And usually when they do LEDs, this is how they put it on the box. They'll have 2 wattages. And what that is this is the real wattage that you'll be using. You know what I mean? This floodlight that they're selling needs 13 watts of power. Okay. This first number they give you, that's what it's comparable to. It's comparable to a 90-watt regular light bulb. You look up on the chart, 90 would be right here, regular light bulb, right above 100. And look at the lumens, 1400. See how it's right in between there. But they both, a 13-watt LED and a 90-watt regular light bulb, both produced 1,400 lumens, which is well above the 1,000 lumens that we said the sun gives us, right? So if you put this light up to your face, like right to your face, it's going to be just as bright as the sun if you just look up at the sun and look at it. It should be even brighter because it's 1,400 lumen, right? So that should definitely be good enough. But the reason why it doesn't matter is because they're $7. Okay, they're not $100 million. You don't have to go online and have a credit card and find it and do some kind of weird thing where you're trying to convert because LEDs need a special they work on DC, you know what I mean, and they can work on AC, which is another thing that I guess I should have brought that up. Is if you work an LED on AC, you have a sine wave for the electricity, right? And when the electricity is up on this way, it will produce the light, but when it's on the down low, it turns the light bulb off, turns it on, turns it off, turns it on, turns it off. And it keeps flickering it on and off, on and off. Of course, this is moving so fast, the sine wave, you can't see it turning on and off. It's impossible. It's doing it too fast. So it looks like it's just a constant light. But it doesn't really matter. But half of your power isn't coming through, you know what I mean? When it's on the down low, it shuts the light off. But it doesn't matter. That's irrelevant. But that's just a little FYI on the side. But my whole point is you can buy 4 of these light bulbs and it still only costs you 4 times $7. So with tax, $30 for 4 bulbs that are these, these floodlights that are LED blues. And you can just surround your reaction with those 4 bulbs, you know what I mean? Or floodlights, all just shining all directly into the same place. You can also use mirrors. Put the blue light on one side, and on the other side of the reaction, put a mirror. And watch this. All right, now look, this is like your reaction mixture. That hose is coming in. That's your chlorine, and you have your toluene. Here you're refluxing it, and here's your condenser. There's your heating source. I just put a flame just to, put something there. But my point here is this. This LED cannot take heat. Okay, LEDs do not like heat. I mean, the nice thing is most of them don't heat up themselves. I don't know if this one does. I know it won't heat up as much as a regular floodlight. But you should maybe put a piece of glass because all visible light will go through glass. As long as it's transparent, it'll all make it through. So just put a piece of glass in between and shine your light. Get it right up to the glass, an inch away, so it's not touching the glass. And, and this glass here will take the heat and reflect it away so that the light bulb isn't getting too hot. And the other thing is the mirror. You can put a mirror on this side right here, right? Over here. And then when your light shines this way, it'll hit that mirror and bounce back so that, a lot of the light that you lost is bounced back into the reaction. Okay? You can put three mirrors, one, in front, one in back, or one on both sides and one in the back. It'll shine in and just bounce off, and then maybe even put one behind this light, so that it almost is closed in by a mirror. The other thing I already said in the benzyl chloride video how you should cover up everything before the tube, where the tube it's not in contact with any toluene. You should cover that all up with tin foil to get no light should go in there. The same way with your chlorine apparatus that's making the chlorine to bubble it in. Everything should be covered with tin foil big time. And then the light should not only be shined where the chlorine is bubbling out here, right? You should have this whole round bottom flask should be having light on it all the way up to halfway up to the condenser. Because you want any chlorine that might have escaped, because you're going to be refluxing this stuff, so you will have, vapors of toluene in the condenser, right? And you want that light up there just in case any chlorine makes it up that far. The light will turn it into a free radical and it'll react, hopefully making the benzyl chloride before it escapes. So have your light from the bottom of the flask all the way to the top, halfway up the condenser. Now we'll be doing my first free radical halogenation this winter on DCM, that's dichloromethane. And I'm going to try to make tetrachloromethane. And I'm just going to use blue light. I'm not going to use any sun, no UV, no violet light, no green light or any longer wavelengths than that. And then I will move on to the benzyl one, just to see how good to get the intensity right. Maybe I do need two bulbs. So I'm going to start out with one bulb and go from there. I think I'm running out of time here, so I'm going to have to cut this off. But you all have a great day, and always remember, science is great.